Okay. Now let's start with chapter 2, which is measurements technique. You have to measure many things through the practical exam. When you ask to measure something, you have to use devices, okay, like meter rule, like micrometer. You have to look perpendicularly to the object when you measure. So your eye have to be perpendicular to the point, okay? And you have to remember to start from 0. So here the length is about 1.6 centimeter. If you are not start from 0, let's say this is the ruler, and here maybe 2, and you finish at 4.5, let's say. So the length is 4.5 minus 2, which is 2.5 centimeter. So you have to look perpendicularly to avoid line of sight error or parallax error. That's your eye, the reading, and the object on the same line, okay? On the same line. If you look from another place, like here, if you are not perpendicular to the reading, you may have another value which is wrong, or from the other side. So the reading is larger or smaller than the real value. You have to check zero error all the time to check that your ruler is truly right, okay? Now, we have a meter rule which consists of 100 centimeters. We have a ruler which is from 0 to maybe 10, 15, or 30 centimeters. Not all the rulers are the same. You have to avoid parallax error in all these ruler or meter rule. To measure smaller thing, you have to use the micrometer. In micrometer, at the beginning, you have to check zero error. Zero error, that the horizontal line here, this one, have to be parallel or on line with 0 on this movable screw, okay? Now, if you have a reading after you put the object between these points, okay, if you want to find the diameter of a ball, small ball, okay, so you have a reading like this. Let's see here. Here the value is 5.5, 6, 7, 8.5, okay. Here the value is 8.5. You see the last number seen on this rod, okay? Then take the number on this screw, okay? Here the value which is parallel to the black line here is 36. Divide this number by 100, so the reading is 0.36. Add this number to your value, so 8.5 plus 0.36 is 8.86, and the unit is millimeter. This is the reading of the micrometer, okay? Now, if you look at the graduation of the barrel, it is measured here 4.5 each one, and here 1 for each value. And we have the vernier caliper. The vernier caliper is used to measure bigger things like this ball. This is larger than the first one. And there is a difference in the error for each device, okay? You have to remember the errors in each device, okay? For a meter rule, the error is about 1 millimeter. So you have to add or subtract the error from your value. If you have, let's say, 200 millimeter, so your value is 200 plus minus 1 millimeter. Why 1 millimeter? Because you have an error from both sides, error from left side and error from right side. Each one is half the smallest division, so the total error, half smallest and half smallest, which is the smallest value in the ruler, which is 1 millimeter. Okay? Now, let's back to micrometer. The smallest value you can measure is 0.01. Okay? In micrometer, this is the error, 0.01 millimeter. In vernier caliper, 0.1 millimeter. In meter rule, it is just 1 millimeter. Again, in ruler, the error is plus minus 1 millimeter. In micrometer, the error is 0.01 millimeter. In vernier caliper, it is just 0.1 millimeter plus minus. This is the absolute error of the values. We have two types of errors, which is the absolute error and the percentage error. The range of the meter rule is 1 meter, so you can measure 1 meter. The maximum value is 1 meter for the meter rule. You can measure values which is less than 1 meter. In micrometer, the range is 50 millimeter is the maximum value. Okay, and this is the error as we mentioned before. In vernier caliper, the maximum value is 100 millimeter, and this is the error in vernier caliper. So you have to check zero error at the beginning, okay, before you start use any of these devices. Let's try to find the value of these micrometers. Here the value is 0. The 0.5 is not seen here. So we said that we have 0 plus. Now, here we have 5, 10, 11, 12. Take this value and divide by 100. So the value is 0 plus 0.12. The value is 0.12 plus minus 0.01 millimeter. This is the absolute error. This is the value. So your measurements must be 0.11 or 0.13. Your value is between these two numbers. Now, let's see the other one here. We have 15.5 plus 10, 11, 12, 0.12. So total is 15.62 plus minus 0.01 millimeter. So this is the way to measure the length of small things. Now, when you use a barometer or manometer or any device like beaker have water inside, you have to take the bottom of the meniscus if you have water, but if you have mercury, you have to take the top of the meniscus. Now, to measure the mass, we use the electrical balance or top band balance. If you want to measure liquid, the mass of the liquid, you have at the beginning find the mass of the empty beaker, then find the mass of the beaker and water, then subtract the value of the mass of empty beaker from the mass of the beaker and water. In this way, you can find the value of the mass of the liquid inside the beaker. Using the protractor to measure the angles, you have to start from 0 here and measure the angle. Let's say you have this angle and we want to find the angle here. We put the protractor like this, and take the angle between this point and this point. The error in the protractor is plus minus 2 degree. So if your value is 30 degree, the value is 30 plus minus 2. This is the way to find the angle. Or you can start from 90 till the value here and subtract this angle from this angle to find this value. To measure the time, we use a stopwatch. You have to check zero error at the first and then take your measurement. The error in the stopwatch is about 0.1 second plus minus. All of these are the absolute error. So we have the absolute error. It is 1 millimeter for meter rule, 0.1 millimeter for vernier caliper, 0.01 for micrometer, 2 degree for protractor, 0.1 second for stopwatch or clocks or what device you want to use to measure the time. As the error smaller, it's better, okay? But we can't avoid the error by any way. Now, we can use the cathode ray oscilloscope to measure the time or the period. What is the cathode ray oscilloscope? It's a small device, like the device used to find the pulses of the heart, okay? And if you take the distance from this top point to this top point between the crests, and you know what is the value of each small square is, let's say 20 millisecond per each centimeter. So to find the period, which is the time taken for one complete oscillation, you have to find the values of squares here. We have 10 squares. Each square is 20 millisecond, let's say, per centimeter. So we have 200 seconds, okay? It's very easy way to find the value of the period. After you find the value of the period, frequency equal 1 over period. Here in this example, each 5 small squares is 1 centimeter. So from crest to crest, we have 2 centimeters only, okay? And each centimeter is 20 millisecond, so the period is 40 millisecond. If the signal is not like this, it is changed like this, you have to take the distance between 2 points which are the same to find the value of the period. This chapter is for students in AS and A2, so some things are not given for you now. It is just for A2 students. Here we talk about the ammeter, which is connected in series in the circuit, and voltmeter, which is connected in parallel. We have 2 types of meters in measuring current or voltmeter. We have a digital one and we have analog one. What is the difference between analog and digital? The digital devices can give you very small error and you can find the value very accurate, okay, or very close to the accurate value, and the error is very small. Here in these devices, the error is just 0.1, okay, so the value is 39.3 plus minus 0.1. In analog devices, you can't find the value very accurate. Why? Because this arrow is not exactly at the middle point or where. You just take the value which is close to the value you can see on the device. Here the distance between the crest and this line, it is the amplitude of the value. You have to be careful about the distance here. The examiner may change the distance here. Here he take each 5 squares as 1 centimeter. He maybe take each small square as 1 centimeters. Again, here we have the errors. We have for a meter rule, the error is 0.1 centimeter, which is 1 millimeter. For vernier caliper, 0.01 centimeter, which is 0.1 millimeter. For micrometer screw gauge, it is 0.001 centimeter, which is 0.01 millimeter. Okay, now we have two types of definitions for accuracy and precision. What is the meaning of accuracy? It is the degree to which measurements approach the true value. Let's say I wanted to find the value of acceleration of a free fall, which is 9.8 meters per second squared. If my values were 9.8 or 9.82 or maybe 9.9, here 9.7, my values are around the exact value. So my readings are accurate. Okay? But if my values were 11.2, 11.3, 11.5, 11.8, these values are precise. Why? Because all of these values around the same number, but it is not the true value. So these are precise. So precision is determined by the size of random error in the measurements. Okay? Here my values are accurate because it is around the true value. Here my values are precise because my values are around each other. So this is the difference between accuracy and precise. I can say that these values are precise because these are around same value. So these values are precise and accurate. These values are precise, but these are not accurate because the value is away from the best value or the good value. Here we have the stopwatch. The uncertainty is 0.1 seconds, as I mentioned before. In the ammeter, the error is about 0.1 ampere. Now, I can measure the diameter of a ball by put it between two set squares, okay, and I put a meter rule here and take the difference between this point and this point to find the value of the diameter. After I find the diameter, I can find the radius by divide this value by 2. Now, we have another difference between systematic and random uncertainty or error. What is the difference between systematic and random errors? Systematic errors or systematic uncertainty will result in all reading being either above or below accepted value. Okay? Again, systematic uncertainty will result in all readings being either above or below the accepted value. This uncertainty cannot be eliminated by repeating readings and then averaging. Instead, systematic uncertainty can be reduced only by improving experimental technique. Examples of systematic uncertainty, we have the zero error in instrument. Okay, we have wrongly calibrated scale. If you try to calibrate the device and you calibrate it in a wrong way, we have the reaction time of experimenter when you're measuring the time. So this is the definition of systematic uncertainty. What is the definition of random error? You may ask about the definition of random and systematic. The random uncertainty is a reading being scattered around accepted value. So if I have values are in random distribution, this is a random uncertainty, but if your values are in one side, upper or lower the value, so we have a systematic uncertainty. As I mentioned before, the systematic error can't be uh, eliminated easily, but in random error uncertainty, reading being scattered around accepted value, so random uncertainty may be reduced by repeating reading. Okay, if you repeat the reading and take the average, so you can eliminate the effect of a random error because you take the average. Now, examples of random errors like reading a scale, okay, particularly if this involves the experimenter's judgment about interpretation between scale reading, timing oscillation, or taking reading of a quantity that varies with time, or reading scale from different angles. That's to say, maybe sometimes when you measure the length of something, you look from this side or this side. So you have a random error. If you repeat the experiment and take average and you measure each time from different side, so you can eliminate this effect of error. Now, combining uncertainty. For quantities which are added or subtracted, give a final result and actual uncertainty. For a quantity which multiplied together or divide to give final result, add the fractional uncertainty. Now, if we have the value x equal y plus z, the error in x is delta x, the error in y and z is delta y and delta z. So in this way, I add up the error in each value. Okay? Let's say I have a equal b plus c or minus c, and to find the error in a, you take the absolute error in a plus the absolute error in b plus or minus absolute error in c. Okay? In measuring the error, you only take the positive values. Okay? You take b plus c, you add the errors only without subtract them. Okay? Now, so if the values are added up or subtracted, the way to measure the error is the same. Don't put the negative sign, just you put the summation of the error in each value. Okay? This is for the values which are added up. Like this example here, we have the current I equals I1 plus I2, and the current was given here 2 plus minus 0.1, 1.5 plus minus 0.2. So the total current is I1 plus I2, which is 3.5, and the error is 0.2 plus 0.1, which is 0.3. So your value should be between 3.2 to 3.8 ampere. So the error is added up. If the values are added up or subtracted, this is used only if we have values which are added or subtracted from each other. What I have do, if my values like this, it's multiplied. Okay, if I have multiplication between the values, like let's say V equals I times R. How can I find the error in the voltage? In this way, I have to take the error in X over X equal the error in Y over Y plus the error in Z over Z. What about A? A here is constant. We have no error in constant value. Let's talk about the voltage here. Delta V over V equals delta I over I plus delta R over R. So I take the error in the first value and the second value and add these up. Okay? Now, again, if I have x equal y plus z, so the error in x equal the error in y plus the error in z. If I have x equal y multiplied by z, the error in x divided by the value of x equal the error of y over the value of y plus the error in z over the value of z. Now, if I have a value like this, which is constant, the constant value is not taken in calculation, okay? So you take it out like a here, we omit it. What if the value is like this, t squared? If I have x equal y to the power 2, so delta x over x equal 2 delta y over y. What if x equal square root of y? So delta x over x equal 1/2 the error in y over y. Why? Because square root of y, it is y to the power 1/2. Here we have v equals by r squared times L. So delta v over v equal by is constant, so no error. Now 2 delta r over r plus delta L over L. Okay, so in multiplication, I add the absolute errors, okay? And if the values are adding up or subtracting, I just add the values of error itself, the absolute value. Please try to solve these questions in your book, and we will solve more questions later, inshallah. That's all which is needed in this chapter. And goodbye.